Okay, welcome everyone. So this is the lecture on 6.3, the law of cosines. And just like with the law of sines, right, the law of cosines is used to solve oblique triangles, right? So triangles that don't have a right angle. And it's used for two scenarios, two cases, right? The first one is when we have two sides and an angle between them given, right? So SAS situation. And the second one when we have three sides given. Okay, so let's look at that law. Okay, and there are three different formulas, three separate formulas. First one is for a square, b square plus c square minus 2bc, and then cosine of a, angle A. The second one is for b square, as a square plus c square minus 2 of the same, so ac, times cosine of that angle, right? And the last one is for c, so b square plus a square, or a square plus b square, doesn't matter, 2ab and cosine of c. Okay, so this is the law. It's maybe a little more complicated than the law of sines. Anyway, let's look at a couple examples and see how it works. Solve the triangle ABC, and what is given is an angle and two sides. So B is 22 and C is 35. Okay, so let's make a sketch of the situation, and we will mark the angles and the sides the same way as with the law of sines, right? So if this one is A, B, and C, so this will be my side A, side B, and side C. Right? So this is 35. This is unknown, and B is 22, and this is 52. Okay, so so my philosophy in solving a triangle like this is to try, the law of sines first, because it's just simpler. So let's use maybe A over sine A, and then B over sine B. Alright. So if we put the numbers in, right, let's put the numbers in. So A over sine 52 equals B is 22 over sine B, right? So we see that in this situation we have two unknowns, right? So A and angle B. So we have one equation, we cannot use it to solve the triangle, right? We cannot begin solving the triangle using that law. That's what I'm trying to say. So we need to use this one, and since I'm given this angle, right, also given B and C, right, I can solve for A, for side A. So let's use it. So A square will be B square plus C square minus 2BC and cosine A. Okay, so A will be a square root of B squared, which is 22, so 22 squared, plus 35, squared, minus 2 times 22 times 35, and times that cosine of, I'll write it here, times cosine of 52. Okay. So I'll show it to you on the calculator just once. Okay, so we have that a and square root, so 22 squared plus 35 squared. Then I have minus 2 times 22 times 35 and times cosine of 52. So cosine of 52. And you see I'm doing it in one step, right? You don't have to do it in one step, especially if you don't have a calculator like this, with those parentheses. Anyway, and then right, I press enter and I get my number. So you guys see, right? This is a probably irrational number. My phone, unfortunately, is about to die. Anyway, I'll finish this example and then I think I'll charge my phone and show you the second one. Anyway, so I think your book says that that you should round it to one decimal place. So it's going to be 27.6. So this is 27.6. This is length A. Okay. And now, so this is given now, 27.6. Let's use, now we're going to use the law of sines. Okay, so well, we can use this particular rendition of it. So I'll have my 27.6 over sine of 52, and that equals, and b is 22 divided by sine of b, right? So we'll be solving for that angle b. Okay, so solve for sine of b. So we're gonna get 22 times 27.6. No, 22 times sine of 52. So these two and divided by 27.6. Okay, so if we put it in the calculator, right, and then take an inverse, we're gonna get angle B is 38.9 degrees. Okay, and then we solve for C by simply subtracting both of those angles from 180. So minus 52 and minus 38.9. Okay, so we get C equals 89.1 degrees. Okay, as usual, we'll list our complete solved triangles with all the sides and all the angles. A is 27.6, B was 22, and C was 35. Okay, and then angle A was 52, angle B was 38.9, and angle C was, what do we have here, 89.1. Okay, that's that. This is what we solved. And this is the final solution, right? So this length was rounded, approximated, right? So as well as this one and this one. Okay. All right. Yeah. So one more lecture. Unfortunately, my phone is about to die. Okay.